I'm the calculus professor, and today I'll be talking to you about arc length. In problem number 15, I'd like to find the arc length of the curve y equals x to the 4th over 4 plus 1 over 8x squared on the interval from 1 to 2. All right, let's start by looking at our arc length formula. Arc length is integral from a to b of square root 1 plus f prime of x quantity squared dx. I have my function y over here. Y is x to the 4th over 4 plus 1 over 8x squared. We're going to need a derivative of that function, so let's go ahead and take it right now. So here's my function. My derivative, y prime, is going to be equal to, well, the derivative of x to the 4th over 4 is x cubed. What's the derivative of 1 over 8x squared? Well, this is the same as x to the negative 2 over 8. And if I take the derivative, it goes down 1. So I bring down the negative 2, and I get negative 1 over 4. And then this would become x to the negative 3, which on the bottom is x cubed. So I get x cubed minus 1/4 of an x cubed. Now, if you don't love this and you're kind of confused of how did I take this derivative, just be more careful. Write this as x to the negative 2 over 8. Take the derivative using the power rule, and this is what you'll come up with. All right, so we have our derivative. Now we're ready to plug that derivative into the formula. So here's our formula. And so our length, in this case, is going to be integral from a to b. In this case, our a is 1, our b is 2. So from 1 to 2 of the square root of 1 plus the derivative, which I have sitting right here, which is x cubed minus 1 over 4 x cubed quantity squared dx. So we have a little bit of work to do here. First of all, let's square this out. If I do, I get integral from 1 to 2 of the square root of 1 plus x cubed squared is x to the 6th. 2 times the first times the second is minus 1/2. The second one squared is plus 1 over 16x to the 6th. All of that dx. All right, the only thing that I see right now is that this 1 and this negative 1/2 could be combined. So I'm going to do that. And I get integral from 1 to 2 of the square root of x to the 6th. I'm going to combine these two into plus 1/2, and I get plus 1 over 16x to the 6th dx. Sometimes it can be a little bit hard to see it, but this actually factors. So x to the 6th plus 1/2 plus 1 over 16x to the 6th actually factors. And what it factors to is integral from 1 to 2 of the square root of x cubed plus 1 over 4x cubed quantity squared dx. And if you don't believe me, just square it. X squared cubed squared is x to the 6th. 2 times the first times the second, the x cubes cancel, and 2 over 4 is 1/2. And this guy squared is sitting right there. So this is a nice little trick to take something inside, see that it's a perfect square, factor it, and now we can pull this guy out of that square root. Now we have integral from 1 to 2 of x cubed plus 1 over 4x cubed dx. And that's something that is quite easy to integrate. Let's integrate it. The antiderivative of x cubed is x to the 4th over 4. The antiderivative of x to the negative 3 over 4 is I bump up the power by 1, so I get x to the negative 2. And then I divide by the new power, minus 2, so I get minus 1 over 8x squared. And I want to evaluate that from 1 to 2. Let's plug in the 2. When I plug in 2, I get 2 to the 4th, which is 16 divided by 4 is 4. Minus, plug in 2, I get 2 squared, which is 4 times 8 is minus 1 over 32. Minus, now I'll plug in 1. I plug in 1 here and I get a 4th. And plug in 1 here and I get minus 1/8. Okay, we're very close. Let's just finish it off. A common denominator for all of these guys would be 32. So let's get everything into a common denominator. 4 is 128 over 32. Minus 1 over 32. Then I get minus a 4th, which is minus 8 over 32. And then minus times minus is plus. So I get plus an 8th, which is the same as plus 4 over 32. Let's add all those together. I get 128 minus 8, which is 120, plus 4, which is 124, minus 1 is 123 over 32. And let's just check that one more time. 128 minus 1 is 127. 119 plus 4, 123. I feel good about that. And so 123 over 32 is the arc length of this curve over this interval. And we're done.